Example 5. In a circle of center O, central angle AOB has a measure of 5 pi over 4 radians. The area of the sector formed by central angle AOB is what fraction of the area of the circle? So if I draw, I draw a circle like this, and I have the center like this, and I say, well, this is 5 over 4 pi like this. This is 5 over 4 pi. And I want to find the area of this sector right here. And the question is, the area of the sector formed by central angle AOB is what fraction of the area of the circle? I know the entire circle here, this entire circle has uh, uh, an angle of 2 pi radians, right? The 360 is 2 pi radians. And that 2 pi radians is actually correspond to the area, which is the same as pi r squared. Now, we want to find the ratio. Now, let's say this is A. So this is A, which corresponds to 5 pi over 4. So the question is the area of the sector formed by central angle AOB, which is this AOB, is what fraction of the area of the circle? So that means A divided by pi r squared is what we are looking for. And that should be equal to 5 pi over 4 divided by 2 pi. Right, which is equal to 5 pi over 8 pi. You can see that, right? And the pi will cancel, and therefore their ratio will be 5 over 8. As simple as that, right? So, and notice that you probably might have noticed that most of these problems here can be solved using simple proportions. When you're dealing with sectors, you're dealing with the arc length, you can always use the 2 pi or 360 degrees as a central angle, and then the area being 2 pi r. So the area being pi r squared, and then the circumference being 2 pi r. To do this simple proportional ratios to find whatever they ask you to find. And so usually dealing with the sectors is not that difficult. The diagram may prove to be a little tricky, but once you use proportions and ratios, you should be fine.